I remember explaining to my mother about, I didn't know what they were called yet, about numbers that always had a 2 or a 4 or a 6 or an 8 at the end. And when you started doubling things, you always ended up with that number at the end. And she said to me, you know, those are called even numbers.
Richard Feynman when Richard Feynman won the Nobel Prize in Physics in 1965, I think. And Richard Feynman's father raised him with the idea that he was going to be a scientist. And started him out from the time he was just a toddler, still in his high chair, with patterns. And Feynman would say the easiest way to describe what math was patterns. And he said it was harder to describe what science was, but patterns was what math was. And his father would put patterns of different foods on the high chair, on the tray, and ask him what would go next. And he would make complex patterns. And first he would start easy, a pea, a carrot, what would come next? Then he'd do 2 peas and a carrot. And then he kept changing it up. But from very early on, his father, who turns out he was just a uniform salesman, but wanted his son to be a scientist, and just figured he had to learn how to do mathematics. And the way he did it was he just kept playing these pattern games over and over. And so I think that isn't something similar said about boys and girls who play with Legos and tend to be a little stronger in math.
But he was interested enough to, the child was interested.
It was a game.
Enough.
His father made it.
It had to be both sides, somebody presenting it and somebody
Right.
wanting to do that.
Yeah, he made a comment that his mother would say, "Oh, that pattern's too hard." But his father just kept always doing these patterns always with him.
If you had to give a piece of advice to math teachers, I guess all math teachers, but particularly that would be working with young, grade school students, what piece of advice would you give them? Because certainly, your interest started at a very early age, and I think most people that have a disciplined mind, be it history, math, science, for most people it does start at an early age. It doesn't have to, but most people it does. What can teachers do to encourage that disciplined mind to flourish or to showcase itself?
One thing that I think needs to happen more in lower grades is that they need more hands-on activities. Like, for example, having big baggies of pattern blocks that you just put on the tables that they get to play with. Now, I have taken my pattern blocks with me to OCTM and NCTM conferences and had talks with teachers. And they were sitting at tables and we put the pattern blocks on tables, and it's just wonderful to watch because the pattern blocks get open, they get spread out, and immediately everybody starts assembling them into all kinds of different little things, and they try to be creative. And this is before we've said a single word about what we want them to do with the pattern blocks. Okay, so this actually helps the kids to see how things fit together. And then you use those pattern blocks to think about things like symmetry, or which pieces, how many of which piece can you put together to make a different size piece. And then you get into the idea of fractions and so on and so forth. There's all kinds of things you can do with them. But I started out by saying about how abstract math is. I think, and I don't remember which math researcher or which educational researcher said this, but you can't abstract out from something you don't have a basic physical feeling for. You need to start with something concrete in order to be able to abstract from it. And so that's one thing. If you can come up with some kind of an activity which engages them, which has pedagogical, mathematical, etc. kind of content to it, but which they'll enjoy doing, then then it's not wasted time. And you can kind of channel all that energy. And then they can have fun. And part of the thing I'm trying to get everybody to realize is math is fun.
I have a question about the engaging work. I know that a lot of school districts are moving sports and engaging work, which I agree with. However, because we're making work so engaging, especially in subject areas like mathematics, what would be your suggestion? Because they're doing so much engaging work and they're allowing you to use all these manipulatives in order to figure out these answers, but then when you get a standardized test or a test in general, when you are giving that child something to measure their ability, they don't have those manipulatives that are engaging with, in which they use on a daily basis. So how do you recommend that a person balance the two? See what I mean?
One of the reasons why we like to have our facts memorized is because we like things fast. You know, you can solve all kinds of math problems by doing them the long way and counting things out and so on and so forth, but when you get past a certain point, it just takes too darn long. But if you've got your basic facts memorized, then it doesn't take so long, you know? And so one of the things I think to get the kids to memorize would be to remind them that they like things fast, you know, and so, but overdoing speed tests is not a good thing either, because one of the things I discover when I start talking to my college kids is half of them loved speed drills when they were in grade school because they always won them. The other half of them hated them because they could never keep up. So, but the way my third grade teacher had us, was it third grade? Yes. Had us start memorizing the times tables was when we started working with multiplication, she had us drawing rectangles on graph paper. And so we drew rectangles that were 2 units this way and 3 units this way, and then we counted the squares, and there were 6. And then we drew rectangles that were 4 units this way and 2 this way, and we counted the squares, and there were 8. And we did that for 3 days. But by the end of the 3rd day, we knew that 2 times 3 was 6 because we had counted those darn stupid squares so many times. We were sick and tired of them. And why was she making us do this? That's when she got out the flashcards. After we had drawn rectangles to go with all of the times from 1 times 1 to 9 times 9. And we had been drawing these things for 3 days, and we were just sick and tired of it, and we had figured out the answers, and we were just ready for the flashcards. So, but I don't think kids make that transition on their own. I think you have to guide them through that. So they've got the manipulatives, and they can see the manipulatives, and they're physically using the manipulatives, but they also need to have the opportunity to see how to do the abstraction. Or get so annoyed with having to do something that's getting too tedious that, how can we speed this up? How can we speed this up? We can speed this up by actually having the numbers in our heads. Because I think there's definite reason for people to memorize things. But you don't memorize for the sake of memorizing. You memorize it because you want to know things fast. You know, it's
Technology.
okay, that black box with the buttons on it is a tool. And there's times to use it and there's times not to. And so when I'm teaching the elementary education majors, I always make them do things by, actually when I'm teaching my math majors, we do things by hand first. And we see how the whole process goes by hand. And then we see that this by hand business is going to be nice, but look how much opportunity there is for silly mistakes. And if we want things accurate, let's help have the technology help. Technology is a tool. We use it as a tool. It's not a crutch. And so if it becomes a crutch, there's something wrong.
What did you try?
The rectangles, when she said the numbers
Oh,
didn't work out.
1, 2, 3, 4 blocks this way? And how many this way?
3.
Okay, and so how many blocks are there?
12.
So we've got 4, and we've got 3. And 4 times 3 is 12. Can I get 12 another way? It's another way of getting 12.
6 and 2.
So if I do 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 2, 6. So I've got 2 this way. How many did I need this way?
6.
So this is 2 to get 12. Is there another way to get 12 besides those two?
One of those.
Oh, 1 times 12. Like this? Now you have to make 12 lots out of it?
Right.
What happens if I do 4 times 4?
That's 16.
You sure?
Yes.
I see the box.
We're on fire like that.
The last time I heard.
Where's the table?
Yes.
Well, let's see. There's 4 this way, there's 4 this way.
That's 16.
Yes.
Okay.
Boy, if I had to count those dark blocks for 3 days, I don't know.
Right.
But then, remember, our parents, they would send a little paper home with our parents, and our parents would drill us.
You're welcome.
But you just
Wow.
used a big sheet of graph paper
Yes.
and just did
Yes.
many of them on one day.
Right. So they didn't have to draw their own, so they didn't have to draw, it's supposed to be a graph paper to draw it on.
Carter talks about starting off understanding the discipline. Just by the way, you talked about being age 5 and being the tutor in your class. What came next in your development of your discipline mind? If you started out knowing that you had this talent and others appreciated that in you and started fixing you up with people that needed your help. But then, what are the next couple of steps that you took in becoming a disciplined mathematician?
Well, my next step is very, the word is idiosyncratic because it's absolutely unique to me. I grew up on an army base in Germany. My dad was a historian that worked for the United States Army, documenting the aftermath of the Second World War and doing all kinds of stuff that ended up in classified documents. So, the United States military forces run schools for their kids all over the world, and wherever they have enough that they've got families there. My parents didn't think that I was being challenged. So when I was 10 years old, now in the German school system, everybody goes to kindergarten, everyone goes to 1st, 2nd, 3rd grade. The end of, in 4th, the end of 4th grade, everyone takes a test. And the test determines whether they go into what's called the gymnasium or whether they go to what's called the Realschule. Now, the Realschule would be similar to our regular grade school. The gymnasium would be more geared toward being kind of almost starting high school. Okay?
College prep almost?
It's college prep. And you have to be a gymnasium graduate to go to the university. So that would definitely be college prep. So kids get tracked. Now you get to take that test at the end of 4th grade, 5th grade, and 6th grade. So you get 3 tries to get into it. And then kids who either score really low or have more interest in becoming people who are into technical kinds of things, they go into an apprenticeship program at the age of 12, where they spend some time working on the job and some time in school. And Germany also has a 6-day school week. So, when I was 10 years old, at the end of 4th grade, my parents decided that I needed to be in a German gymnasium. And so I got taken out of the American school system and put into a German school. And I'll tell you, that's one way to learn the language really fast. The very first one of my academic grades that went back up to its normal A was my math. So that was, and I can't explain that except that because I learned all 5 fractions in a language that was not my native tongue. You know, the only way I can explain that is numbers are numbers.
What are the things that challenge you now in terms of math? What are you working on?
The whole thing that's behind how we actually get computer graphics to work, the fractal geometry and chaos theory, which is one of the newest branches of math. And that's one that has practical application right away. One of the things that I strongly suggest, almost to the point of requiring it, is that the math majors have to become learning center tutors for precisely that reason. I know if they can explain it, then they probably know it.